Eddie the magic monk. Eddie the magic monk. Eddie the magic monk. Eddie the magic monk.
Hey guys, it's Eddie the Magic Monk. How are you going? We're going to continue with our anti-differentiate using partial fractions tutorial. And I want to now talk about a slightly harder version of the problem. Okay, so we've got a fraction we want to anti-differentiate. So let's try this one. Anti-differentiate x squared plus x plus 4 over x squared minus 2x minus 3. Okay, and we want to anti-differentiate it. So if we try to split it with the partial fraction technique we talked about earlier. So let's try that. X squared plus x plus 4 over x squared minus 2x minus 3. And I try to split it. Firstly, I don't know how to split it because I have a quadratic down the bottom. Okay, you can only split it into two if you change it into two brackets. So let's do that to the bottom first. X squared minus 2x minus 3. If you guys remember how to factorize, I can then put it as x minus 3, x plus 1. Okay, if you try and expand that, you should get this this quadratic. If you don't know how to do that, go back to some of my factorization quadratic tutorials. So now I can go x minus 3, x plus 1 here, and then I have a and b like that. Okay, so I can do the first part, but if I try to keep going from that, okay, then on the left hand side I have x squared plus x plus 4 over x squared minus 2x minus 3. On the right hand side I then have a times x plus 1. Sorry, on the bottom it's x minus 3 x plus 1 because I'm combining the two fractions by adding them. So I have the top times the bottom on the other side plus the top times the bottom on the other side. Okay, so I do that. So the bottom is equal, but then if I try to make the top equal, okay, so then I have on the top, if you look at the top of both fractions, and then have a x plus 1 plus b x minus 3. Now this will never be equal. Okay, why won't it be equal? Because on the left hand side I have x to the power of 2. It's a second degree polynomial. Okay, highest power is 2. But on the right hand side, if you expand that out, it's just ax plus a plus bx minus 3b. The highest power of x is 1, so they're different degrees. So this will never work. Okay, if you try to do it, it won't give you the answer. So we can't continue like this. We've got to think of another way. Okay, so let's just wipe all that out. It's not going to work. So the second way we're going to do it, okay, in order to split it, is we're going to write it all out again. Obviously, when you are stuck, just write it all out again. Okay, then we're going to think of some way to split this up. Okay, what are we going to think of to split it up? We're going to pretend that we split it up by having two fractions. And on the bottom, I'm just going to put x squared minus 2x minus 3 on both sides. Okay, and then I'm going to copy the denominator again here. You'll see why in a second. Okay, now what can I fill in this spare section here? so that when these two fractions add together, it'll give us this. Okay, I can put something here that'll allow me make it so this equation is true. So x squared plus nothing is x squared, plus minus 2x plus something will give you x. Okay, so what is it? Minus 2x plus 3x. Okay, minus 2x plus 3x will give you x. You can see that here. Minus 2x plus something gives you x. So you can also go box equals x plus 2x is 3x. So that's how you get that. Now plus 4 here, minus 3 here. So again, it'll be plus minus 3 plus 7. Okay, is 4. So now this equation is correct. That equation is now correct. So because these two things are equal, I can then change that to equal. So this on the left hand side, copy that down again, just so we can see how it is the same. So on the right hand side, I have a fraction 1 plus, okay, now I can use partial fractions to split this up, can't I? I can go 3x plus 7. So I'm just going to copy that down to help us understand how to split it up again. So I've got 3x plus 7 over x squared minus 2x plus 3. Okay, I'm going to turn the bottom into two brackets multiplied by each other. X minus 3, x plus 1, as talked about earlier, how to factorize a quadratic. Okay, and the top is still the same. Okay, then I can do the partial fraction split. X minus 3, x plus 1, a, b here. And I'm going to now combine these two fractions by using the adding fractions technique. A bracket x plus 1 plus b bracket x minus 3, as talked about in previous tutorials, how to add fractions. So now we have this fraction and this fraction are meant to be equal. So since the bottom is equal, the top must be equal. 3x plus 7 equals a x plus 1 plus b x minus 3. Okay, so how would I continue from that point? We have let x equal negative 1. So I have 3 times negative 1 plus 7 equals negative 1 plus 1 is 0. A times 0 is gone. Plus negative 1 minus 3 is negative 4. Negative 4b. So we'll keep going with that. So I have 3 times negative 1 is negative 3. Negative 3 plus 7 is 4. 4 equals negative 4b. B equals negative 1. So I have what b is found. Now we're going to find a. So let x equal 3. 3 times 3 plus 7 equals a bracket 3 plus 1 plus b 3 minus 3. So that's gone there. 3 times 3 is 9. 9 plus 7 is 16. 16 equals 4a. A equals 4. So b equals negative 1. A equals 4. I'm going to try and put that into here. 4x minus 3 plus b is negative 1. Negative 1 x plus 1. So that part has been split. Alright, this is now being split into this. Okay, it's being split. Really good. So now I can put that over here. 4 over x minus 3 plus, well, I just go minus 1 over x plus 1. So this whole equation, which was given to us in the problem, has now been split into this, which makes it super easy to anti-differentiate. All right, so I'm just going to copy down the question again. Put it over here. Okay, so that, before we even anti-differentiate it, we will change this equation now to our newfound method. Using our newfound method, we change it into this. Okay, dx. Anti-differentiate with respect to x. Okay, so now let's keep going with that. Okay, how do you anti-differentiate 1? That anti-differentiates it to x. Okay, because x differentiates into 1. ln x minus 3, it's going to differentiate into 1 over x minus 3. But because there's a 4 here, I'm going to put a 4 here as well. And then I have ln x plus 1. There's a 1 there, don't need to do anything, plus c. Done. Okay, and if you want to do a little check just to see that this differentiates into this. So if y equals x plus 4 ln x minus 3 minus ln x plus 1, okay, y dash would equal 1 plus 4 times ln, so 1 over x minus 3 minus 1 over x plus 1. Okay, so this does differentiate into that, so it's correct. Alright, so this is the final answer.